Okay, so let's take a look at today's lesson. We're going to be looking at derivatives of inverse trig functions. Just when yesterday we learned about logarithms and derivatives of logarithms, and you're thinking, oh, I need some more formulas. Give me more formulas. Here we go. We have 6 more to memorize. So let me talk about these and kind of help you maybe with the technique that I use for memorizing them. These are for the arc functions. We remember that this is not an exponent. It's an indication that it's an inverse. Kind of confusing. The notation is confusing. I really don't like it, but we need to be comfortable with it. That's what it means. It does not mean 1 over cosecant. It means inverse cosecant. Or I prefer to call it arc cosecant. To me, that pretty much, it's the inverse function. And that's what I'll be calling it when I'm talking about. These are the arc functions, the inverse trig functions. So these derivatives, they look kind of complicated, and they kind of are, but they're really important. When we go to integrate, these derivatives right here are going to pop up all of the time. So just a little bit of a precursor on, we remember when you learned how to FOIL and then you learned how to factor. Remember that process? The foiling process was fairly straightforward. You could figure that out. The factoring process was a little bit harder. That's kind of the relationship between derivatives and integrals. Derivatives is kind of straightforward. You just kind of do the derivative. Integrals are a little bit more complicated. And when we get into integration, they're going to have this. I mean, we're going to have to integrate these. You're going to have to recognize what they are. So pretty important that we have these memorized. These derivatives take the same note, like if it starts with a C, it's negative. So it's the same kind of, as far as the sign of the derivative, it's the same issue. If it starts with a C, it's negative. So arc cosine is negative, arc cosecant is negative, and arc cotangent is negative. So that pattern holds. The other thing is actually quite nice. Other than the sine, we really have, these are arc sines and arc cosines derivatives are exactly the same except for the sign. So really we're just having to memorize one formula knowing that one is positive and one is negative. And look at arctangent and arc cotangent. Their derivatives are exactly the same except for the sign. And lastly, arc cosecant and arc secant derivatives are exactly the same except for the sign. So really we have 3 formulas to memorize, just keeping straight which is positive and which is negative. All right, so within that, usually, I think typically students usually don't have a really hard time memorizing arctangent. It's just 1 over 1 plus x squared. These two, the ones with the roots, we tend to get mixed up. And I'm going to tell you what I do to help me remember which way it goes. Maybe it'll help you, maybe it won't. But look at the arc cosecant and the arc secant. See how they have the absolute value of x on the outside here? And what I think of is, on this one, the x squared that's under the radical is close to it. I just think about proximity. The x squared is close to that, so therefore it's x squared minus 1 instead of 1 minus x squared. See how they're opposites? So that's what helps me, is just to remember, okay, well, in this one, the x squared comes first, so it can be really close to the absolute value x. That's all I've come up with to help me memorize that. And so these are the derivatives. Now, if for some reason, maybe you forgot them, it actually is possible to do them by hand. It's kind of fun. All right, I wrote you the instructions out down here to find the arc functions derivatives by hand. It takes several steps and a little bit of time, so really your best bet would be to just memorize them. But it is possible to create them from scratch with this relationship. We have y equals arc sine, and we switch the x and the y to get sine, and then go through this whole process doing implicit differentiation and using the triangle to rewrite it, and we get actually the derivative. So I don't know, maybe you might have some time to play with it on tonight, Friday night, maybe, I don't know, but it's possible. I mean, it's kind of fun. So questions on the actual formulas themselves. We're going to apply them in just a moment. One thing that we need to be aware of is that if there's anything in the argument other than x, we have to chain it. Anything in the argument other than x, we have to chain it. And chaining this is a little bit different because it's like a preset formula right here that doesn't include just an x. So let me talk about how we would chain it, and then we'll go practice some. So let's say, for instance, we'll just do this right here. Let's say we had a 2x in here, a 2x. So if I had a 2x in here, I would have to put the 2x here and here. Everywhere there's an x, I would put the 2x. And then I would multiply by the derivative of 2x, which is 2. Okay, so we basically use this formula as a template to substitute into, then we multiply by the derivative of the inside. Okay, so that's basically what it boils down to. All right, well, let's take a look at we have a few problems on the next page to practice with. And since we are not accustomed to the formulas yet, I mean, we just looked at them, I'm going to write the formula for arcsine down, just so we have that as a reference. So it's 1 over square root of 1 minus x squared. That's the formula for the derivative of arcsine. All right, we're going to use that formula, and we have something other than an x. It's a 2x. We're going to take that 2x, and we're going to substitute it in for this x. So we have the derivative is equal to 1 over square root of 1 minus. Okay, we're going to open up where that x is and insert the 2x. So I have done that portion of it, that substitution. My next step would be to multiply by the derivative of 2x. And the derivative of 2x just happens to be 2. Okay, so now it's a matter of just cleaning it up. So d dx is going to equal 2 over square root of 1 minus 4x squared. And that's basically all we can do. Okay, that's our very first arc function derivative. We okay with that? Okay. So let's look at the next one. And again, I'm just going to write down the formula for the derivative of arc secant up here. So that is 1 over absolute value of x times the square root of x squared minus 1. That's the formula for the derivative for arc secant. In this case, it's a little bit more complicated argument. It's e to the 2x. So what I'm going to do is I'm going to insert e to the 2x right here where that x is and right here. And then we're going to multiply by the derivative of it. We're going to chain it. So let's do that. So d dx is going to equal 1 over absolute value e to the 2x square root of e to the 2x quantity squared minus 1. Okay, so I substituted my argument in. Now I have to multiply by the derivative of it. The derivative of e to the 2x is e to the 2x times the derivative of 2x, which is 2. Now, I've had actually a lot of confusion on derivatives of e to the x, so I want to give you in general how this works. So if I'm going to take the derivative, we're going to call it e to the box. Okay, anything can be in there. Anything can be in the box. So I'm going to take the derivative of e to the box. What I get when I do that is e to the box. I get that. Then I have to take the derivative of whatever the contents of the box are. Okay, so that is a formula or format for the derivative of e to anything. Okay, so in this case we did derivative of e to the 2x. The derivative of e to the 2x is itself e to the 2x times the derivative of the box, what's in the box, which happens to be 2x. Derivative of 2x is 2. Are we okay with that? Okay. All right. So that notation, that e to the box, is one of my professors always said that and just stuck in my head. It's like, okay, I can do e to the box. Just anything can be in the box. It's fine. All right, it's like a little present, right? It's like a little present wrapped in a box. We get to take the derivative of it. So now let's work on simplifying this. Let's notice this right here, e to the 2x. E to the 2x. Is that always positive? It is, isn't it? It's impossible for it to be negative. So we really don't need the absolute value bars for it. That is a consideration that we have to make with these. Once we're simplifying, we really need to think about that. We need to make sure that whatever we're left with is positive, because that's what we're supposed to have. So in this case, it's always positive, so no worries. We can actually cross it out like this is in the numerator, right? We're working on simplification. So I can cross this one out with this pretty safely since it's always positive. And so I'm going to be left with 2 over the square root of, so e to the 2x squared, power to power is multiplying, so e to the 4x minus 1. And that is my simplification for that problem. We okay with that? Okay. The last one requires just a little bit more. We actually have what I hope you recognize as a product. So my overall template is going to be the product rule, but I also have to, within the product rule, deal with the arctangent derivative, which is a formula. So I'm going to write it over here. So arctangent is 1 over 1 plus x squared. That's the derivative of arctangent, just so we have a reference for it. So we're going to need to do fg plus fg, first things first, second things second. Okay. So let's do that derivative. So this would be f, and this would be g. So we take the derivative of f, which is x. Derivative of x is 1. Then we copy and paste g. So 1 arctangent square root of x plus. Let's work on the second part. We're supposed to copy and paste f, which happens to be x. So write down x. And then take the derivative of g. So the derivative of arctangent is this formula right here. And so I want to substitute into the formula, and then I want to chain it. So we have 1 over 1 plus, we're going to substitute square root of x in place of that x in the formula right here. And now I need to multiply by the derivative of the square root of x, which we could probably do in our sleep now, right? You've done the derivative of square root of x so many times. So the derivative of square root of x is 1 half x to the negative 1 half. Okay? And that's what we're going to multiply by. So now let's start simplifying. This first term right here is really not much to do to that one. Just 1 times the arctangent is just arctangent. Arctangent square root of x. Okay, this one we have a little bit of work to do. Hopefully we recognize that little piece right there is going to turn into an x, right? The square root of, and we square it, it's going to be x. So here I have 1 over 2 square root of x, right? 1 over 2 square root of x is right here. And here I have x in the numerator. So I have x to the first, and the denominator I have x to the 1 half. I need to combine those together. Right, and that's going to give me, if I have x to the first in the numerator and x to the 1 half in the denominator, it's going to simplify to be x to the 1 half in the numerator. Right, so I'm just going to write that as the square root of x. So square root of x over, then we have the 2, and then 1 plus x. You can certainly distribute the 2 if you want to. That will be fine. Or you can leave it just like that. And that is simplest form. Okay, how are we with that one? Okay? So here I have, I'm going to rewrite it for us over here on the side. So this x went to the top, and then I have this 1 plus x here. And this guy right here went to the bottom like that. And so I basically have x to the first and x to the, this would be to the 1 half. And I'm using an exponent rule. 1 minus 1 half would give me 1 half. And leave me with just x to the 1 half in the numerator. Is that okay? Okay, any other questions? Alrighty.